Hello everyone and welcome to this SCADAConnect Simulator demo, in particular using SCADAConnect Simulator to project forwards several different scenarios, what-if type scenarios into the future. So as you can see, I've got my SCADA historical scenario made current over here, and so I'll just go ahead and give that a run first up. We'll have a look at some of the starting features of SCADAConnect, and then we'll go into projecting it forwards after that. So as you can see, I've run this simulation over 24 hours, and as I do that, the first thing I can do is zoom in our area here and have a look at the real-time flow. So if I use my element symbology refresh here, as you can see, I can just view the real-time flow straight on my WaterGEMS interface here, so I don't have to go back to any SCADA web interface or anything to get the current value of my actual system flows, pressures, pump on and off status, and so on. The other thing I can do without really going into SCADAConnect Simulator itself is immediately graph SCADA versus model results. So instead of going to pipe 1 here and graphing it and then having to manually add SCADA data, what I can do is just right click straight here on the SCADA element and graph that, and then it'll immediately show you both the SCADA graph and the model graph. So the model is the blue one and the SCADA are the red dots, and you can see that down here at the start at 2 hours here, both the model and the SCADA come on at pretty much exactly the same time there. So that's showing me that the on level for my pump here is probably exactly correct. Now down here when the SCADA turns off, SCADA pump turns off at about 6 hours here, you can see that the model continues pumping for an extra 2 hours. So based on that, you'd say that probably the off level of this particular pump is incorrect, and that may need to be fixed in the controls. But the point being that you can very quickly go around, graph things, and even alarm them with color coding and so on to show you where you've got discrepancies between your model and your actual historical SCADA results. So what we'll do now is jump into SCADAConnect and start doing some what-if scenario projections forwards. So if I open up the SCADAConnect simulator, before I start to do any calculations or projections, if you go to the Configure tab, you'll see Import Initial Settings here, and what I can do is grab the historical settings from the start of my simulation time so that I know exactly what the tank levels and pump on and off statuses and so on were for the start of this, so that I can then project it forwards with the correct starting value. So when I OK that, it's going to update the scenario for me, and I'm able to then compute within SCADAConnect Simulator, and you'll notice here that I've got my demand adjustments and control overrides turned off. So what we're saying is, if we leave everything as is without any changes and just start projecting forwards 24 hours, these are the results that we're going to get. So I can use the time browser here to play through my entire simulation on my SCADA interface here. So you can see that as it plays through the time browser, my actual SCADA interface is updating. You can see that tank level is now changing and pump 1's on. So just regarding the HMI that we've got here, this is an example mocked up by us, but the idea being that if you were to do this with a real world SCADA system, an organization SCADA system, that you wouldn't mock up your own one like this. What you would do is go to the SCADA system and take a copy of that interface and then use that interface. So the idea certainly isn't that you have to create your own. It's that you would take a copy and view your results on your particular SCADA interface that you're probably already familiar with. Certainly anyone who uses your SCADA regularly would be familiar with your interface. In terms of this particular simulation, you can see that the tank basically fills up when pump 1 is on, and then it starts to empty when pump 1 turns off, and it doesn't go either high or low, so it's working as you'd expect. You know, a pump and tank in that situation would work with no problems. You might have also noticed that pump 2 didn't come on at all during that simulation. So now that one's done, what I'm going to do is turn on these control overrides, and these are very easy to create and apply. So if you have a look, I'll just open one up. But basically, create a new one, the entire network for every demand, and all I'm doing is multiplying them up by 1.8. So essentially just increasing the demand by a certain factor to see what's going to happen in our system. So when I apply those, I of course need to recompute it. And now when I play it through again using the time browser, we should see some slightly different results. So again, I'll play it again, and this time at the start you should see something similar. The tank value drops a little bit. Of course pump 1 comes on, but now with our increased demands as we go through, you'll notice that it continues to drop the tank level despite the fact that pump 1 is on. So what's going to happen now is that as it's getting to the busy part of the day at 8 AM or whatever it is there, tank continues to drop, and then you'll see pump 2 is going to come on. So it gets to the secondary level where 2 pumps are required. A second control kicks in, pump 2 turns on. Once pump 2 turns on, the tank level starts to rise again. So it didn't get to the red level, we didn't have any problems, but what we did notice is the second pump did need to come on because of those 1.8 factor demands. So I'll just let that play through to the end. And now what we're going to do is run through a maintenance type scenario, or maybe even a pump issue. So what we're going to do is use a control override to turn that pump off and then see what happens throughout our system. So instead of having to change controls and different things within our actual model in the components menu there, what we can do is from within the simulator create control overrides. And so this is very simple to make again. And all I do is select the pump element, or the element that I want, in this case pump 2, and then just take the status and turn it off from our start time for 48 hours. Now it's only a 24-hour simulation, so we're just saying turn it off for the whole time. So you can see that it's very easy to go and create one of these control overrides rather than having to go into your model and modify or delete or create a new control alternative. So a very quick and easy way to control your entire model without having to make any changes in the actual model. So I'll give that another compute. And this time down the bottom here, before we even start, you can see that the tank is empty at 14.073 hours. So when I time browser this, I'll give that a play and run it through, you're going to notice that it is going to be empty. So the notifications down the bottom, these are model notifications, so these are telling us that they're general notifications that you would expect from any WaterGEMS model. So they still appear despite the fact that we've run it from inside of the simulator. So we still get the notifications that you'd always expect. Now you'll notice here that our tank level is going to go red when we drain it, but there are no alarms that pop up in my SCADA system, and that's simply because this is a little example SCADA system. If you took a copy of your real system, any alarms that you had pre-configured normally on your system would be going off now. So now that that tank is drained, you would be seeing your actual SCADA alarms and whatever your operators are used to seeing there in terms of low tank levels or low levels. So you'll get both the user notifications that you'd expect from the model, as well as the visualization in the simulator SCADA interface, as well as any SCADA alarms that would generally go off in that situation. So just to sum it up, what we've done is we've firstly taken all of our current values for that day or for that time and imprinted those into the initial settings. So whether the pumps are initially on or off, the tank levels, of course, valve closures, and anything else that initially might affect our model. We'll then run it forwards to see what's going to happen if there's no changes to the model, which we saw play through pretty easily. Then we can start to play with the demands and the controls, so turning things on and off and changing demands up and down depending on what may be happening tomorrow. Maybe you've got something special occurring, it's a public holiday or something. So you can start to project things forward, both in your model with those alarms, alerts and notifications, and then back into the actual SCADA simulator interface, or the SCADA interface that most of the people in your organization would be used to viewing. Thank you very much for taking the time to watch this video.